Welcome to another GC Basic tutorial video. Call it what you like. This is for the 16F175 chip family. And today we're going to do part 7, which is making the LEDs that we've set up already flash in a sequence. We're going to use a switch to make them go forward and backwards visually. So I have noticed on all the previous videos that one of the components was not the correct chip. Now I did think I saw a message from someone saying it was something about a chip. Never really understood what it meant, but I just spotted it. So I've now corrected the chips. I'm using a 16F175xx. So as I said at the beginning, we're going to use a switch. We're going to use the ADC for delays, and we're going to make the LEDs flash. We're going to do it in a sequence, and we're going to reverse them using a switch. Well, that's going to be the actual event that's going to occur. So I have assumed you've installed the software, you've got your programmer working, you've tested, you've got the 16F working, you've got some LEDs, you've got a potentiometer and some switches because you'll need all those. Now I'm going to show you what I've got here shortly in terms of looking at my desktop and on my lab. But what we're going to do, we're going to pull it all together and we're going to use the LEDs, have them rotate in a sequence. When I push the switch, that's going to control the direction. I want to make it quite clear I'm using the master switch as an input and not a reset from the last tutorial. We're going to use the ADC to read the voltage and set our delay, and we're going to use time, and that's in terms of the wait command. So, saw this diagram last time. I've got some switches, I've got an ADC and an LED, and I'll show you how that's sort of hooked up quite easily, because I'll show you on physical hardware. So what I'm going to do is going to initialize the microcontroller. We're going to do a for loop forever. So we are going to read the ADC, we're going to determine if the switch has changed, and if it has changed, we are going to rotate the LEDs left or right. And then dependent upon what the value of the ADC was, we'll have a weight. So we can change the rotational speed. In terms of what I've still got this diagram. Port A, I've got a switch on port A3. Let me bring my little pen up. Port A3 here. ADCs on A.0. 4 LEDs on port C, 0, 1, 2, and 3. And I have still got hooked up the switch on the master clear, but won't be using it. I'm just making sure you understand where I've got it. So look what I've got. Look at desk cam. So here we go. I've got a chip, 17556 sitting here. I have 4 LEDs hooked up, seen those before, a potentiometer, and I have a row of switches here on the left hand side, but I'm only going to use one of those. And what it is, as I press that, the LEDs will rotate. So the connectivity of this, ping me if you really need it, but essentially what I've got is the LEDs connected to the microcontroller via suitable resistors, and they're probably on this board 330R. I've shown you how to do the pull-ups on the switches, and I've shown you previously in previous tutorials how to connect the potentiometer. Not going to review that, go back to the previous videos. So what I am going to do, I'm going to bring up some code. I'm just going to type in GCS, which is GCStudio, and hit enter. It will bring it straight in, and we're inside of GCStudio. Again, as before, I'm going to open up the folder for the chip demonstrations, but whilst we're in here today, I was just going to have a quick hunt around and just show you what's inside the spanner. Inside the spanner, you can actually change your environment. So there are a series of boxes on the bottom left-hand side and it says edit programmer preferences. Well, we will go into some detail of that later on. We could reset the whole programmer. We can clone our programming tools. We can reset the whole environment back to factory settings. You can create a dump file that might be needed for support. You can force an update to update the whole environment. And you can export your GCStudio settings to Visual Code. Now, those are 6 right now. There's one more than previous. There's 7 things you can do. We may ask you to do some of those during a support ticket. Now, what we've actually got, this is a fully managed environment. So you have up the top right, you have the update channel. And normally you'd leave that on mainstream. There are options in there where you can say, don't give me any updates at the bottom, just give me the compiler and give me a dev preview. There aren't any dev previews at the moment, so I would just leave it on mainstream and just get the latest and greatest. In terms of the IDE, you can actually push this into an older version of the IDE called SynWrite. You could use the graphical IDE and you can use VS Code itself. So you can change those parameters. We would leave it, and I'd recommend you leave it in GC Code. In terms of the compiler architecture, we support 32-bit and 64-bit. You can choose, but if you do it on auto, it's fine because it will just automatically select. But if you're wanting to change it, you can. Don't know why you would, but leave it. I leave it on auto. And then in terms of GCStudio, in terms of there's a modern and legacy. If you select legacy, it will just take you straight into the old IDE. You won't get the updates, etc. Bad practice. Just stay with modern. And if you really do hate Visual Code Studio, then GC Code IDE, just select it in the IDE channel. There are some other options here on the right-hand side, and we'll come into those at a later date. So go back. So that was the spanner. So let's have a look at these demonstrations, and we'll just crack them open, and we are now sitting in the IDE. Control B to open up the options we need to do. Now I shut down and rebooted and stuff, so I go Control F. In here, I always go Control F. Oh, I'm so sorry. Control F GCB, and just filter with that little down arrow there on the GCBs, and it will show you just the GCB source files. Now what we're going to be doing is 090 reversible LEDs with a variable delay. 090 reversible LEDs. And we'll look at that code. I'm just going to shut that window, Control B, and there are other options to do it. Let's get to the top of the code. Lots of comments, all in green, that's fine. No changes to all our constants. We are setting so we have some constants. One for the LED port we're using, that's C. If you wanted to change the LED, I would recommend you change that as well. We have the 4 LEDs on RC0 to RC3, so we set those outputs. And then we have our potentiometer and switches, constants defined, and then we set those as inputs. We saw that before. Now, this time, a few more constants. I've defined one called down and up because we're going to need to use those later on. I create some variables, which I will come on to shortly, all byte slot, direction, my delay, and LEDs. And then, because we are going to be changing the direction, I need something that holds the direction of travel. So I have one called LED right and LED left, and they're constants, and they're set to 0 and 1. Now, there are other ways of defining constants, and we will look at those later on. But essentially, what I'm doing is saying that if it's going to the right, it's equal to 0, and if it's going to the left, it's equal to 1. So I set the direction, the initial direction, that's that byte value, to LED right. So it already knows it's going to the left or right. Now you could use bits here. It's up to you. Have a play. We saw this before. The next part, which is I defined a macro, which essentially just resets everything back to 0001, which is equating to off, 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 and on. We had a mask previously, and the LED mask will just strip out those extra bits that are inside of the port. Now, We haven't got anything connected to it, so we're not going to get any spurious data. But if you were doing this on a real system, you might need a mask. And then I've got a variable called LEDs, and we're actually going to be rotating this variable. So it's interesting. Let's get started. Do loop. There's a do loop in here. Let me just minimize everything in here. Look, if you press this little down arrow, you can sort of compress all the code. So you can see in one part of the editor, do loop. There's a do loop forever. The first part it does, it gets in the ADC value, puts it in a variable called my delay, and then scales that between 1 to 200. We saw that before. Why are we doing that? Because that's what we're going to be using that. Down here in the wait, we're going to say wait, and we now know that's going to be between 1 millisecond and 200 milliseconds. So first time through, we know that the direction is, we have a variable called direction, and we are going to rotate the variable LEDs to the right. Now, if we do the else on this, look, we do the rotate to the left. So look at that, that's quite clever. So we can see what happens. So if I rotate things to the right, do you remember from a previous tutorial, you can check this C called the carry. And if you know the carry has been set, then you can actually reset the process. So if I'm rotating things, I can check that value. Now, what I'm then going to do, if it's equal to 1, I reset it. That's the reset value. And so if it has equal to 1, I just set the initial state again. And so I set the LED port. Remember, that was port C effectively. And I just say, mask off the existing values, therefore nothing changes, and then set it to the LEDs which we've just rotated. So essentially what we're doing is we're just dropping the LEDs. We're clearing out the existing values and dropping in our new value with our or statement. So you've got and statements and or statements. So when it moves to the right, you do it one way, and when we move it to the left, we're looking for something else. We're saying if the LEDs is equal to 32, that means we've rotated our variable, and essentially with the variable, LEDs, it's just going to double in size. It's going to go 2, 4, 8, 16, 32, job done. And then what we do, if it's equal to 32, we just mask off the other bits and just set it to 1. And it's exactly the same assignment. LED, mask it off, and then we OR it to set those bits that we're interested in. So essentially, what we've got is values going 16, 8, 32. Is that right? Let me just work it in my brain here. 1, 2, 4, and 8. It's going 8, 4, 2, and 1. And when it goes back in the other direction, it goes 1, 2, 4, and 8. And when it's 16, it puts it back. Let's see it in action. Let me bring up, and I'm going to go into my IDE, press function key F5. It's now programming it. And what we're going to see is some LEDs going one, and there they go. Pop, pop, pop. They're popping away. Now, they're going in one direction. So let me just see if the delay works, because that was the first operation that we did. They're going faster until visually you cannot see them on the camera. Actually, I can't make them out on that either. So I'm going to zoom in so we can see it. Zoom in like that. Move the camera down a little bit for us, because we just want to see that when I push that switch. So you can see that they are now moving. I'm sorry about the flashing for those who are sensitive, but you should be fine. Let me just set that like that. So now if I push this switch, which was attached previously, the moment I release it, it changes direction. It's now going Are we sure that's slow enough, Evan? Let me just check. Let me just slow that down a little bit. There we go. I'll push that switch with my little thing here. It's going from the top to the bottom, bottom to the top. This is the classic microchipped low voltage programming board demonstration. What we've done, we've built it up. We have set some LEDs. We've read the potentiometer. We've used lots of variables. We've used AND statements, OR statements, wait statements, scales. We have done a tremendous amount that is really quite feasible within this very, very easy program. We've done a lot of work, but as you can see, it works great. Use my finger this time, going upwards, going downwards. And you can see I can change that in the middle because that's just the way the program works. Great. Let me just restore that back to my desktop. So, what we're going to do on the next demonstration, we're going to change tack. We're actually going to start using some of the more complex components within the microcontroller. We're going to use serial UART, so they are synonymous, to display the values of that ADC. That as we read it, we're going to display it on the screen. And with that, we'll call it a wrap.